Wu is Dr. Qiusheng Wu is an associate professor and the director of graduate studies at the Department of Geography and Sustainability at the University of Tennessee, Knoxville. And I will turn it over to him for the rest of his presentation. I would ask you, if you have questions, please throw them in the chat. We'll stop at about 12:50 and take some time to answer any questions. So please hold your questions to the end or in the chat. Yeah, go ahead with your presentation, please.
Okay, stop sharing. All right, thanks, Kristen, for the introduction, and hello, everyone. Good afternoon. And so for today, I'm going to talk about some of the open source tools that I have developed, and also some of the open access data that might be useful for environmental monitoring. I sent the links to the slides in the chat. You can also scan the QR code to get access to the slides. So I have a lot of demos. You're welcome to check them out later if you're interested in a particular example. And so here's the outline. I'm going to briefly introduce some of the packages that I have developed and cover a variety of topics from data visualization to data analytics. And at the end, I will show you some of the additional resources you want to learn more about some of these open source tools. And so I cover primarily 4 packages: GMap, LeafMap, segment geospatial, and also the most recent one on GeoAI. And first, I would like to briefly introduce Open Geospatial Solutions. So this is a GitHub organization that I created 2 years ago, and it houses some of the open source packages and data catalog, and also interactive web apps that I created. And there are a lot of links in here. You're welcome to check them out. It's all free and open access, and anyone can utilize them and contribute to those repositories. And the first one I want to introduce is called GMap. So this is the Python package for doing interactive visualization and analysis with Google Search Engine. For those of you who have not used Google Search Engine, it's basically a cloud computing platform that allows you to access a lot petabyte of data and also run analytics. It's free for research, education, and also non-profit. So it is very powerful, and it's one of the most popular cloud computing platform for geospatial. And this is a package that I created a couple before, right after the pandemic, so 4 or 5 years ago. And it has been widely used and officially adopted by Google. So if you want to learn Google Search Engine, if you want to use Python, then you might be utilizing GMap. So you can check it out on the official Google Search Engine documentation. Next, I'm going to show you some of the key features and what kind of things you can do. So you can easily source all kind of geospatial data, and then you just select from the drop-down list. Then you can visualize the data easily, just a couple lines of code. Nice thing about this, you don't have to download any data. So if you ever need to work on national or global scale studies, in the past we have to download the data, and then you need to have a lot of data storage. Even if you have the data storage, you might not have the power, the computing power. So now with Google Search Engine, you can easily search any data, visualize them without downloading any data, and it's very powerful. And the analysis is just like you can go to YouTube, you can go to Netflix, you can search any movie, you can just watch them and stream the data, stream the movie without having to actually having a DVD-ROM or something to actually to load the movie. So the same idea, we are moving into the cloud. So we want to be able to actually source any data and visualize them. So Google Search Engine has a huge data catalog with over 100 petabytes. So you can pretty much most of the popular data in the public domain is already available there. So you can utilize GMap to actually explore the data and also visualize the data. You can visualize the data interactively. So for Google Search Engine, there's a lot of data, but if you want to visualize them, then you need to write Python code or JavaScript. And so GMap makes it a lot easier. Just like desktop GIS, you can pretty much just load the data, then you can use the interactive graphical user interface to change the visualization. So it can be raster data, vector data, pretty easy to use. So for all example that I'm showing here, there's a icon here, open in Google Colab. So you can actually open that one using in the cloud in your browser, and then you can run through it without having to install anything on your computer. You can also use AI. So sometimes if you're just getting started, you don't know what data to use. GMap also has this data explorer integrated. So you can just ask some simple questions, text prompt. For example, I want to study the temperature changes for a particular location for the last decade, over the last 20 years or half a century. You will be able to figure it out, and then you can recommend the data set for you. Then you can just select the data set, and then you can visualize that. You're also going to show you some recommendations. So it's very easy to use, just text prompt, then you can explore the data for a variety of applications. It doesn't matter. It is going to be temperature, it's going to be forest change, land cover change. You can pretty much ask anything. And then behind the scene, you will use Gemini to actually to recommend all those data, go through all the data sets, and then give you the recommendations. Also, you can create time-lapse animations. So you can pretty much, without coding, open the app, and then you can go to any location of your interest. Then you can draw a rectangle, and then you can just couple clicks. You will be able to generate animations just within 20, 30 seconds. You will get this kind of animation easily. So you can download it to your computer to share with other people. It's very powerful. Without kind of cloud computing, this can take you hours just to create. It looks very simple, but it's not. Like you have to, without cloud computing, you have to download a lot of data. You need to remove the cloud. You need to do the mosaicing. If you're doing a large area, you also need to remove the cloud, do all kind of data processing. But with this, everything is done in the cloud. So you can just simply select your area of interest, then specify, okay, I want to create imagery annually or monthly or weekly, whatever temporal frequency that you want. Then as long as the data support it, you will be able to process all those data and then give you the animation easily just within 20, 30 seconds. So it's super powerful. You can try out the link, actually also the notebook there to do it by yourself. So you can create animation for any location around the globe, and very, very powerful. So these are some of the animation that you can use to do environmental monitoring. So if you are interested in forest change or maybe natural disaster, landslide, those kind of things, if they can be captured by the satellite, you'll be able to create animations. You can, for example, also for weather and climate applications, for example, volcanic eruptions, wildfire, for example. And not only you can capture the images, you can also actually do analytics. So you can, for example, extract the Wi-Fi boundary or something like that easily. And this is hurricanes. So if you're interested in studying the dynamics of these natural events, you can use Google Sensing and Gmail actually to at least see before you're trying to do any scientific research. So all kind of hurricanes that we have pretty much every year. Besides running those as a computational notebook, you can also actually run this one in the cloud. So you can click the link, you can go to my web app, and then it allows you actually to create animations without coding. So you can just open the link in the browser, and then you can just simply use the same user interface. So makes it really easy for you to deploy your own applications on the web so that other people can have access, and they don't need to know how to do coding. You can run through the coding. So the interface that you're seeing here is just a GMap interface that allows users to interact with the Google Sensing Cloud Computing, and it's very powerful. So think about you are creating a web app that allow people to watch movie, any movie that you have directed or you make available, and then they just open the link in the browser. Then they can stream the data. They can, for example, see the water surface changes, and you can do some also analytics. You can easily, for example, create time slider for you to look at the time series images. So in this case, it's just Landsat, but you can pretty much use that to showcase any time series images that you have. And then you can have access to the original data. You can also use the data to get some insight. For example, I want to see the water changes in the solar city. For example, here, you can just draw a rectangle, and then you will run the computation. You can also generate, for example, monthly history. You want to see, for example, how the water dynamics has been changing. So those things are pretty easy. You can see it's all responsive, only a couple seconds. You can get the results without having to actually download the data. And sometimes there might be some natural disasters. You want to see the changes. So Google Sensing has the data updated constantly. You can just use the web app to actually select the pre-event and post-event imagery. And just with a couple seconds, you can request all the data and you can see the changes. You can also run some simple algorithms to just compute, for example, the NDWI, the normalized water index, and then you can quickly see how much of the area have been flooded and without coding. So this just to show you the power of cloud computing and Google Sensing. So all these things can have a lot of variety applications, environmental applications they can use to monitor changes on the surface. And those are just examples. Of course, you can refine the algorithm, you can improve it, you can adapt this to other applications. But what I'm showing you here is you can utilize the cloud computing for free, and you can utilize ZMap to create a web app and then deploy it to the cloud. Then people can just go to the URL, they can try things out without having to actually install the packages, set things up on their local computer. And I also published a book 2 years ago about using Google Sensing GMAP. You're welcome to try it out. It's free and open access. You can check out the link if you want to learn more about that. And I would like to acknowledge this funding from NASA and also Google for supporting some of the work of the GMAP project. So that's about GMAP basically doing interactive visualization and cloud computing with Google Sensing. The next one I want to introduce is LeafMap. So LeafMap is kind of similar to GMAP, but doesn't rely on Google Sensing. So a lot of users really like the interactive functionality of GMAP, but they cannot use Google for whatever reason, and they want to utilize the functionality to visualize geospatial data to analyze. So I kind of took out some of the functionality from GMAP and then put it into LeafMap. So now LeafMap is independent, so you can use it on any cloud computing platforms. And you can use it to visualize all kind of geospatial data, vector data, raster data. And again, it's open source. You're welcome to check out the link on GitHub. So you can source data. So similar to Google Sensing, GMAP, you can source data from Google Sensing. So this one allows you to source data from any open access spatial temporal asset catalog. So if, for example, from AWS, from Microsoft, or from any third-party platforms that provide the data in a state catalog. So you can easily just source data, go to any location, and then source the data, visualize the data without having to download the data. And it's very powerful. So it is just showing you how to access the Sentinel-2 data from AWS. So rather than having to go to USGS or ESA to source and download the data, you can visualize them directly within a notebook environment without coding. And you can also download the data if you want to, but this is showing you you can actually use the interactive interface within GMAP, LeafMap to source the data. You can also source some of the NASA data. So NASA has a lot of data. So this one shows you the NASA Opera dataset. They have water, they have vertical displacement, also a lot of dataset for disaster management. So you can source the data using the web app interface, and then you can easily visualize the data, and then you can see, for example, how the water has been changing at a particular location. It doesn't have to be water, it can be pretty much anything. So you can access the data, you can also query the pixel values, and you can do everything just by using the interface without having to write any line of code. So very, very powerful. And besides 2D, you can also visualize data in 3D. So this is actually a new feature that I just added last week. So just pretty new. So allow you to visualize data on a 3D globe, and you can add any widget to the map. So you can add images, videos, anything, and then you will be able to visualize them on 3D. Nice thing, you can also deploy this one on the web. So if you check out the link on the left side here, it will take you to the website. So you can actually visualize data by yourself, and you can see how powerful it is. Just with a couple lines of code, you can actually create this kind of web apps and then to visualize data easily. And you can also share this one with anyone. So all the data pretty much at the global scale. So you can visualize vector data, raster data. So this one shows you the global building footprint and global building and road network, street, basically the transportation layers at the global scale. So you can change the visualization easily just with a couple clicks without having to write any line of code. So it's all interactive. So basically build on top of LeafMap and then use Solara to basically deploy that one as an interactive web app. So we can change visualization, whether it's point or line or polygon, and it's super fast and also responsive. Again, check out the link. You can play with that by yourself and see how it goes. You can adapt the template to deploy your old data. So if you have, think about if you ever have any geospatial data, whether it's vector data, raster data, it doesn't matter. You will be able to actually visualize them easily. So one of the data set that's very useful is the over-tour maps data. So they have buildings, they have transportation, they have point of interest. You can also try out this link in here to actually see the data. So LeafMap can visualize the data easily in either 2D or 3D. And you can also utilize this one for your local area. You can also download the data, you can improve it. So there are lots of data. So the data itself is a couple hundred gigabytes. It's very, very big. So you can use PM tiles to actually render the tile. So you can just, with just one line of code, you can visualize the global data using LeafMap. Super powerful. All right, so you can also visualize data in real time. So if you sometimes have some applications that you want to update in real time, for example, GPS, hiking trail, whatever, you can utilize LeafMap to actually create these kind of applications. Very, very cool. This is not something you can easily do using desktop GIS, but using LeafMap, you can just pass in the data, and then you can, whenever you have some new updated data, you can bring the data and then show you kind of this dynamic applications. Again, you can check out the notebook here. All the examples are reproducible. So if you want to create something like that for yourself, welcome to check out the notebook and then run your own source code. Besides that web, the LeafMap web app, another one that I want to recommend use is the Maxar Open Data. So they release a lot of high resolution satellite data for disaster management, so disaster response. So when they have the major disaster, for example, earthquake, hurricanes, flooding, they sometimes release this kind of data, but it's not very easy to use. They basically put the data on AWS S3 bucket, and people actually need to download the data. And I created this web app and makes it easy for people to actually visualize the data. So you're welcome to try out the link here. And so next, I'm going to show you some of the common, some of the disaster. For example, this is the flooding in Libya, right? So they have all those satellite data. So create a web app that makes it easy for people to go to the website, and then you can just visualize the data easily without having to download the data. So behind the scene, the data are like a lot of smaller pieces. So I kind of create a virtual mosaic and then just put it on the web so anyone can actually look at that. So this is flooding, but there's also, for example, some of the recent hurricanes in the US, for example, Hurricane Helene and Milton. So they also release some of the data. Again, you need to download the data. It's not very easy to use, but with the web app, you can easily pull in the high resolution satellite data and you can visualize them pretty easily just with a couple clicks. So check out the link. It's very easy to use. All you need is just the web internet access. Then you'll be able to try this out. Okay, so that's about LeafMap. There are a lot more features. You are welcome to check out the website. I only show you maybe a tiny fraction of what the LeafMap can do. It has a lot more features. I also have over, I think, 100 notebook examples. So if you want to learn a particular feature, you're welcome to check out the website, leafmap.org. There are tons of documentation examples that you can learn from. So LeafMap is primarily designed for visualization. And there are a lot of things that sometimes we want to do besides visualization. For example, you want to run some analytics, you want to extract the water, urban vegetation, whatever you like, and you need to write a lot of code. So with the more like recent, the AI becomes so popular, so it can also be used on geospatial data. And one of the popular computer vision model is called segment anything. So allows you to segment object from imagery. So I adapt the segment anything model to geospatial data and then created this package called segment geospatial that allows you to actually create extract basically segment center imagery or area imagery and then extract objects. So this is kind of like remote sensing image classification. So sometimes you want to extract trees or buildings or something from the imagery. You need to actually train the model and then create your own model, prepare the data. It takes a lot of time and effort, but with SameGeo, it makes it so easy. All you need is just give me an imagery. I will give you the label, give you the objects, and very easy to do. So next, I'm going to show you a couple applications. So for example, you have the area imagery, and now you want to basically segment all the buildings. And so just a couple lines code, you can segment all the buildings into different objects. Again, you can check out the link here if you want to try it out yourself. And this looks beautiful, looks colorful, but the model doesn't know what it is. It just knows it's an object. So basically just grouping similar pixels into the same region, into the same object. So, but later I'll show you how some of the ways that you can get the label. So similarly, you can segment agricultural field from the imagery. So these are all like circular objects. So you can segment them into different objects. Then you can calculate some geometry properties. Then you can figure out which one is agricultural field polygons. You can also use points. So those are the previous example, basically unsupervised classification. But this one you can do like supervised. Assume that you want to extract the buildings, but you don't know, you don't have the data. So you can just click a couple points and then you'll be able to extract all the buildings surrounding those points. So keep in mind here, like for doing digitization traditionally, you have to draw the boundary, right? You have to draw along the buildings. It takes a lot of time and effort. But using this segment anything model, you can just create points easily. So you can create actually this building just within a couple seconds. If you already have some point or data from other model, you can directly use that to do segmentation. So this is kind of called hybrid segmentation. Basically means you give me some training data, and then based on the training data, I can extract the buildings for you. But in this case, I don't need the building outline. I just need some points. And then the model will actually be able to figure out that you are trying to extract the buildings. So using a point as the input. So all you need is just an imagery and then some point inputs. Then you will be able to extract the buildings. You can also use bounding boxes. So like, okay, I'm trying to extract trees from the imagery. So all you need is just some bounding boxes, and then you can extract the trees. So rather than having to manually digitize the tree boundaries, if you already have some rough bounding box from other data set, then you can just passing the bounding boxes, you'll be able to extract the buildings nicely. So this is going to save you a lot of time if you're trying to extract something from the imagery that has a very complicated shape. You can just create a point. You can use bounding boxes, then you'll be able to extract the objects. You can also use text prompts. So this is more like using large language models, just like ChatGPT. You can give an imagery and then asking, okay, I want the trees, I want the buildings, and then just use the interface. You'll be able to extract those objects for you. Of course, it's not going to be perfect because the model was not trained on geospatial data, but you can see it still gives very decent results. So you can adjust the parameters, and then just with couple tries, you'll be able to extract the things that you want without having to train the model. So it's just like give an imagery, tell me what you want, and then I give you the outputs. And then of course you can tell more detailed instructions like, okay, the building size need to be within a certain level or something like that. Then you can adjust the parameters to get these kind of things. So all just done with couple clicks without coding. Similarly, I can show like, okay, I want a swimming pool, and then just with the imagery, then you can extract the swimming pool. After that, you can also do some post-processing to extract the swimming pool as a rectangular object, and then you can save the result as geospatial data. It's master imagery or vector data, so you can do it whatever you want. So the package has all the functionality that can help you do that easily. And you can also do some like change detection. So you can use the model to maybe detect the buildings before and after. Then you can just use this to quickly figure out the changed area. Of course, it's not perfect. It's just showing you some of these things, potentially potential applications, and you can certainly fine-tune the algorithm to do a lot more things that you wanted to do. And so besides doing the one single image segmentation, you can also do video. So this is based on the segment anything model too. That means you can, if you are doing time series analysis, for example, in this case, I want to map the surface water, for example, these river channels, using laser imagery for the past 4 decades. So we have over 40 years data, and traditionally, if you want to train the model, you want to classify or extract the water, you need to have the training data for many years, right? But in this case, all I need is just, okay, 3 points in the first year. So if you look at the bottom here, I have this theta imagery, lane set, and then I have perhaps 3 star here, green color. That means, okay, I just roughly tell the model, okay, here's the water, here's the water, here's the water. And that's it. I just tell the model that in 1980s, 1984, this is where the water located, like these 3 pixels. And that's it. And then you can give it 40 years images, and then you will be able to extract all the waters for you without you having to provide training data for subsequent years. All you need is just a bunch of images, just a couple of points, and that's it. The model will be able to figure it out because it has the memory to figure out in the subsequent year. It knows this one belongs, it's correlates the previous one. They also belong to water. So you can use it to basically do all kind of a change analysis. For example, changes of this RC. So all you need is just 2 points. They only need this water, but you also notice there's an island in the middle. And that one I also place a point. That one is a red color. So green color means it's the foreground. Red color means the background. So it means that I don't want like object. So you can see like how powerful it is. You can actually just using 3 points. For the first year, you were able to detect the surface water changes for all 40 years easily, and much more convenient than traditional remote sensing image segmentation that you have to train the model in all the images. You can also use it to do change detection or object tracking on non-geospatial data. So for example, I want to keep track of these 2 cars. All I need is just place 2 points in the first frame, then you'll be able to actually keep track of the car moving in the subsequent frames pretty easily. You can also use it to do maybe volcanic eruptions. So you want to see the impact area of the volcanoes. You can also do that easily just using SameGeo. So those are some of the applications I want to show you. Of course, there are a lot more applications they can do with this kind of technology, but it's all up to your imagination. There are a lot of things you can do. So segment geospatial is just for doing image segmentation. And more recently, they created another package called GeoAI. It's basically go beyond segmentation. So we want to do prediction, regression, or some other tasks that we can utilize AI. So, and it's pretty new. It's still under development, but you can check out the link on GitHub. I also created a lot of examples. So you can use the package to do object detection, and that one you can actually train your own model to actually create your own model and then use that to detect object of your interest. So for example, you can use the model, the package to download the data. So in order to create training models, you also need to have some training data. So you can either use satellite imagery or vector data, raster data. So one of the good data source is the over-tour maps that I saw at the earlier. So it has view building data, transportation, point of interest, and you can download the data for your area of interest easily, and then you can visualize the data. You can also download data from a plain to computer. So it has a lot of geospatial data that allows you to download, and then it's open access. So you can use that to easily source the data with one line of code. So basically just import the library and then say, I want a particular data set. This is the bounding box. This is the time range that I want. And then you will be able to show you all the data. Then you can download them just one line code. So you can download data easily using a package. This is over 2 maps data, same thing. You can just one line of code, say, okay, I want a building for example, for the city of Vancouver, for example, just pretty much 2 to 3 lines of code. You can get all the buildings, rows or anything that you like, and then you can use that one to create the training data. So also, it has a lot of data visualization functionalities, allows you to use the interface. So GeoAI built on top of LeafMap. That means you can use any features that LeafMap provide. So you can just use the interface to source data interactively, and then you can pass in the data to the model to do to build the GeoAI or the deep learning models for doing all kind of tasks. So this is just showing you how to source the DEM, for example, for any location on the globe you like. You can also visualize data in 3D. So I already showed you earlier some of those features. So it has a lot of 3D functionality that you can showcase the data. You can visualize them easily just with couple lines code. Very, very powerful. And you can also create vector data. If you ever need to create training data, you can also use the the interface to create training data. So you don't need to use desktop.js. You can just use the same LeafMap interface, and you can just create the data. You can assign the label, building 1, 2, 3 different lane cover types very easily. So again, just couple lines code. You can see all the snippets in here. You can also edit vector data. Sometimes you might already have some training data you want to actually to edit some of the data so they make it more accurate. You can also do that easily using GeoAI. And then once you have the data ready, so for example, this is a use case. I have the aerial imagery or satellite imagery, and I also have some buildings here downloaded from Overture. Now I want to train the model to do building detection on other imagery that don't have the building labels. And so this is what you're going to do. You only just use the GeoAI package and then just provide these two imagery. One is the satellite imagery, the other one is label. The label can be also be vector data format. So under the hood, the package is going to subdivide the imagery into smaller tiles like this, one by one, and then you have some over there. So this is basically you have the imagery, you have the label, and then we can use this one to train the model, because all the deep learning models, they don't directly take a big geospatial data. There's always going to be image tiles, smaller ones, smaller pieces, and then you feed a bunch of those into the model to train the model. Then going to give you the train model that you can use to do prediction. So this is what it looks like. So you can use DeepMap, GeoAI to create image chips. So all you need is just one line of code. Give me the imagery, give me the label, and then that's it. One line of code, you create corresponding image chips, and then do all the image reprojection if needed, and you just specify some parameters, and that's it. So the data will be ready in a couple seconds. Once you have that, then you can do the training. So this is basically the process of training the model based on the data they created. Again, it's so much easier to use now. Just provide your data and then create image chips, then train the model. That's it. So one line of code, you can train mass RCNA model for doing object detection. So without having to worry about understanding the architecture and how to put things together. So GeoAI makes it really easy. All you need is just one line of code. That's it. And then once the model is ready, you can use it to do inference. So basically, you can use it to apply object detection on other images that you want to do that do not have the labels. So it's the same thing, just one line of code, object detection. Then just give me the imagery. I will give you the output. That's it. This is basically the initial output coming from the model. And then you can do some post-processing. You can simplify the data. For example, you can regularize the building footprints to make it simplifier so there is no, the file size is not too big. So from object detection to post-processing, regularization, and this is what it looks like. So you can have the imagery, it can apply to different area, and then you can see how good it is. Just with couple lines code, you can build your model, you can train your own model, and then you can get the output easily. And so only just couple lines code, and that's it. So very easy to do. Then it will take you a lot of time if you're trying to do this one on your own, build your own model, and then just go through all the deep learning libraries. It's not something everyone can do, but this pretty much it's anyone can do. You can click the notebook, you can run through that by yourself. Very easy to do. This shows you some of the regularization methods. So after you do some object detection, you might want to simplify the boundaries, and then you can use this one to easily simplify boundaries. You can also calculate some geometry properties. So for example, you want to know how many buildings are detected, what's the size distributions of the buildings, what's the orientation or something like that. You can easily just one line of code, you can add geometry properties to all the object that you detected. So this can be very useful to gain some insights directly from the outputs. And so this is kind of the process from downloading the data, visualizing the data, and then train the model, and then run the object detection, and then just do some post-processing. But there are lots of applications. So next, I want to quickly show you some of the applications. For example, you can do building detection, just like what I showed you earlier. So this is basically the popular applications of doing object detection. You can also do solar panel detection, right? So if you have some imagery, you want to detect the solar panels, you can run the same process. You can train your own solar detection models, and then you can just get the result easily. You can do car detection. So if you have certain events you want to monitor, for example, the traffic flow, how many cars throughout the day, you can require the imagery, and then you can train your own model. Then you'll be able to actually count how many cars on the parking lot, right? You can do ship detection. So if you want to see how many ships are parking at a particular time, a particular location, you can also train it. So there's so many, pretty much very generic, any object detection. As long you have the imagery, you have some data, you can train your own model easily. You can also do surface water detection. If you have some high resolution imagery or satellite imagery, you have some water objects, and then you can use this to easily train your own model, and then you can adapt this one to do water dynamics in other locations, because most of the surface water data set is kind of static. You only have one boundary, but it doesn't really consider the changes throughout years. If you want to do this, you can train your own model, and then you can use it to do water mapping. And the last application will be wetland mapping, right? So if you are interested in mapping wetlands, but you don't know how, you have been using pixel-based, but now you want to try some deep learning, you can use this one actually to train your model to be able to detect wetlands. You can see from here, I use the training data from the 1980s. It's very outdated, but I can still use the model to train the model, and then it performs really nice in mapping those wetlands. You can see it not only detect the waters, it also detect the vegetation along the water edges. So it's something certainly has the potential to be applied to large area wetland mapping. Okay, so those are all the applications I want to show you. Like I said, there are a lot more applications. It's you can try to check it out on the website. And right now, the package is mostly focused on object detection, but there will be lane cover classification, change detection, and also trying to integrate large foundation models. So you can keep an eye on the GitHub repository for updates. Lastly, if you want to learn more, you can check out my YouTube channel. So I do publish tutorials regularly, and there are a variety of categories from visualization, analytics to AI. And if you particularly interested in AI, you can check out this tutorial series. I think I've created 18 so far, but more to come. So I envision this can go to easily 50 to 100 tutorials because there's so many applications, and right now only covers image segmentation. So there will be a lot more features to come. So you can check out the link. If you want to learn like programming from scratch, I also have this intro to GS programming class. All the materials are free, open access. You can check out the link. This is a course I took at the university here, but I record the video, so all our video are public accessible. So if you want to learn how to do coding from the very beginning, you can check out the link and then follow through the videos and also tutorials. If you want to learn how to design open source packages and maintain open source packages, I also have a course here that I just finished teaching this spring semester, and it's all free open access. I mean, the course website, the video, so teaching you from scratch how to create a Python package like Gmap and DivMap, and how to publish on GitHub, and also how to create examples, how to create documentation, tutorials. So all the practical tools that I use every day to develop and maintain open source packages. So you're welcome to check out those courses if you're interested in learning more. But if you have any questions, I'm happy to answer any questions. Thank you.
Excellent. Thank you very much for your presentation.
Okay.
I'll just see if we've got any questions here in the chat. We have one from Nilusha. It says, an impressive presentation. Thank you very much. Truly impressed with your work. Let's see.
Thank you.
Yeah, if anybody has a question, please feel free to either throw it in the chat or unmute your mic and ask away.
Yeah, you can also reach out to me later if you have any questions. You can also ask questions on GitHub, so it's all free and open access.
Yeah, thanks so much, Wu. Super impressed. I've been following you for quite a while now, and yeah, very conversant with your wonderful work and your contributions. Quick question. I'm thinking about the transferability of some of the models you've developed. So, are most of your data focused on North America, or is it something that could be adapted to other parts of the world?
Yeah, it doesn't matter. It can be anywhere. As long as you have the data, you have the imagery, you have some label, it can be anywhere.
So,
It's very generic. So all we need is a satellite imagery or aerial imagery, and then some labels, buildings, trees, or whatever you like. And then you can just passing. So all you need is just change the input, the model, and then adjust the parameters. The workflow stays the same.
so great.
Great, thanks. Another comment from Carl says, SamGeo looks fantastic and he'll be looking it up. Definitely there is a few things that you mentioned there that I will be looking up after this. So that is great. Thank you so
Yeah,
much.
feel free to tell the slides. I send the link again, but it's all there. You can look through the examples, demos, and then so for every demo, there's a link to the notebook. So you can actually try it out by yourself.
Awesome.
Awesome. Thank you very much. Well, if nobody has any further questions, do feel free to reach out to Dr. Wu, and I will turn it over to Alex now to speak on what our next webinar will be about. Thank you.
Awesome. Thank you, Kristen. Can you see my screen? Okay, great. Thanks everyone for attending. So just a quick update. We'll be going on a break during the summer, but we'll be coming back in September. We have Jennifer Harold coming from the ABMI, and she'll be speaking on the value of Alberta-focused open access geospatial data to industry and academia. Jennifer has vast knowledge base when it comes to remote sensing applications and utilizing Alberta-specific products that's been generated by the ABMI. So we'll be having some nice, interesting sessions with her. And we also have some other talks planned for the rest of the year. So just be on the lookout on our LinkedIn page and also on our website. And yeah, you'll be getting more information. So thank you so much for attending. And yeah, Dr. Wu, thank you so much for your time. It's really appreciated. And if you have any questions, please do not hesitate. You can reach out to Dr. Wu if you have any additional information or you want to brainstorm. I know there's lots of tools that I'm going to check out, like for the wetland mapping. Yeah, lots of tools that I'd like to utilize in my research. Thank you very much.
Okay, thank you. Take care, everyone. Bye-bye.
Okay, bye.
All right, I guess we can stop the recording now.